In Salah is one of the hottest places on Earth, with temperatures often reaching 50 degrees Celsius. But here, in the heart of the Algerian desert, a project is underway that could help to mitigate the problem of global warming.
We are at the very beginning of a whole new program of dealing with fuels and energy that is responsive to a relatively newly recognized problem of climate change. And Salah fits in because it is developing the technologies and the experience for putting carbon dioxide underground.
There is a growing recognition of the role that underground storage of CO2 could play in our response to climate change, particularly in relation to electricity production. Hydrocarbon fuels such as coal and natural gas can be converted into hydrogen and CO2. The hydrogen can then be used to produce electricity, whilst the CO2 is injected underground into secure geological formations where it would be trapped indefinitely. This offers the possibility of a cost-effective, near-zero emissions electricity generation system. The significance of In Salah is the opportunity to test and develop a range of techniques for CO2 storage, paving the way for the implementation of similar schemes around the world. At In Salah, CO2 is mixed with natural gas in a reservoir being developed by BP, Sonatrach and Statoil. Some 1 million tonnes of CO2 per year has to be removed from the gas before it can be sold. In the past, this may simply have been vented to the atmosphere. But at In Salah, a $100 million project has been set up to compress and re-inject the CO2 nearly 2 kilometers underground, back into the reservoir.
C'est notre responsabilité vis-à-vis au respect de l'environnement de notre planète des générations futures. L'autre bénéfice que je peux mentionner aussi, c'est l'expérience que l'Algérie et les shareholders vont apprendre par cette technique de réinjection et prouver donc au monde que c'est une technique viable, sûre, contrôlable et économiquement rentable, donc pour pouvoir l'utiliser dans le futur dans des cas similaires.
The CO2 is being injected into salt water-bearing rock around the periphery of the area where the gas is trapped. A great deal of work has been done to predict and model its movement.
We would expect the CO2 to be taken up by the water, so there is an absorption component just in exactly the same way as you get Perrier CO2 within water. There will be some CO2 taken up by the minerals, so we would expect some deposition of carbon on the actual matrix of the rock, and then the residual would actually migrate structurally up dip and into the hydrocarbon trap over time.
The fact that In Salah held natural gas and CO2 under pressure for millions of years provides a high degree of assurance that the re-injected CO2 will be permanently trapped in the reservoir. However, the wells that are drilled both to extract the gas and to re-inject the CO2 could provide a seepage pathway. If CO2 storage is to be widespread, it is important to be able to monitor its movement and reactions underground.